This device that I have sitting in front of me here is called a wave machine. So I'm going to start this video by showing you a few simple demonstrations using the wave machine. Let me start by grabbing this end of the wave machine over here, which would be on your left. So now I'm going to shake this end of the wave machine. You can see that when I did that, a bump propagated along the wave machine going from left to right. Because that bump was above the normal level of the wave machine, I'm going to call that an up bump. So that would be an up bump that propagates above the normal level of the wave machine. On the other hand, I can shake the wave machine the other way and make a down bump. So that would be a down bump. It propagates below the normal level of the wave machine. For the next experiment, I'm going to simultaneously create two up bumps. One up bump will start at the left end and travel to the right, and the other up bump will start at the right end and travel to the left. And we want to see what happens when those two up bumps meet in the middle. Could you see that when the two up bumps met in the middle, they stacked on top of each other to make a bigger bump, and then those bumps simply passed through each other? This phenomenon, where two wave disturbances add together to make a bigger wave disturbance, is called constructive interference. Now what I'm going to do is make an up bump at the left end of the machine and a down bump at the right end of the machine. The up bump and the down bump are going to propagate towards each other, and we want to see what happens when they meet in the middle. It's harder to see exactly what happens in the case of the up and down bump together, but I hope you are able to see that when the up bump and the down bump met in the middle, they canceled against each other, so that for just a moment, we had a disturbance in the wave machine which was smaller than either the up bump or the down bump individually. And then after the up bump and the down bump met and at least partially canceled each other, they simply traveled through each other. This phenomenon, where different wave disturbances combine to make a smaller disturbance, is called destructive interference. On the board here, I've sketched out the two demonstrations that I just showed you using the wave machine. In the first part of that demonstration, we had two up bumps propagating in opposite directions along the wave machine. And then when those bumps overlapped, they added together to give a bigger wave disturbance. When two wave disturbances combine to make a bigger wave disturbance, we call that constructive interference. And then after those two wave disturbances combined to produce a bigger wave disturbance, each of those disturbances continued propagating in its original direction. Over here, I've mapped out that second demonstration where I showed you destructive interference. In this demonstration, we had an up bump propagating in one direction and a down bump propagating in the other direction. Now, when I do this experiment in practice, I can never quite get perfect cancellation between the two bumps, but I hope you notice that there was a moment in there where when the two bumps were stacked on top of each other, they canceled, so that the wave machine, if it didn't get exactly all the way to flat, was pretty close. Where two wave disturbances cancel, or at least partially cancel to make a smaller disturbance, we call that destructive interference. And then after those two disturbances overlapped and destructively interfered, each of those disturbances simply went on its way. So now I have introduced you to constructive interference and destructive interference of two individual localized wave disturbances. In the next video, we're going to see what happens when we have interference, not just between two individual bumps. We're going to see what happens when we have interference between two entire wave trains propagating in opposite directions.